Hello, my name is Melanie Hurtado, and I will be doing a presentation on Emmy Noether. Here she is in all her glory. I would like to start off by talking about her background and upbringing. To begin, her full name was Amali Emmy Noether. She preferred to go by her middle name, which was Emmy. She was born March 23rd, 1882, making her an Aries, which is fitting since she was described to have somewhat of a fiery personality. She unfortunately died at the age of 53 on April 14th, 1935, due to an infection after a routine surgery. She was born and raised in Erlangen, Germany, and according to Prize Women in Science, her upbringing could be described as warm, companionable, and above all, mathematical. She was raised by both her mother and father. Her father, Max Noether, was a math professor at Erlangen University. She had 3 younger brothers, 2 of which also had careers in math and chemistry. Germany, unfortunately, was not very progressive in the late 19th century or even the 20th century, so she was unable to attend a college prep school. However, from 1889 to 1897, she did study French, English, and some arithmetic at a school in Germany. She was certified to become a language instructor, but she never used her certification because when she turned 18, she decided that she wanted to pursue mathematics despite being a Jewish woman living in Germany in the early 1900s. So, she started prepping for the entrance exam for Göttingen University in Germany. To prep, she audited classes at Erlangen University where her father worked. Auditing just means that she was able to attend class, but she wasn't receiving any credit for it. After 2 years of auditing, she was admitted into Göttingen again as an auditor. Fortunately, though, in 1904, the University of Erlangen accepted female students, so she stopped attending Göttingen and continued her studies at Erlangen University, where she earned her PhD in mathematics. After earning her PhD, she started working at the University of Erlangen, and a lot of her work consisted of research. She had 2 students, and sometimes she would fill in for her father during lecture. She unfortunately worked there without pay from 1908 to 1915. In 1915, she was invited to teach at Göttingen University by fellow mathematicians Hilbert and Klein. She did get paid while she worked there. Unfortunately, she wasn't being paid as much as her fellow male colleagues. She also helped the 2 assist Albert Einstein in proving the theory of relativity, leading her to develop her own theorem, Noether's theorem. As I mentioned previously, she was a Jewish woman living in Germany in the early 1900s, so I think it's prevalent to talk about what life was like at that time, because while Hitler did not become Chancellor of Germany until 1933, he still heavily influenced people, and anti-Semitism was still really strong during that time. Students at Göttingen even expressed that Aryan students want Aryan mathematics and not Jewish mathematics, and many German students even wore stormtroopers, swastikas, and brown shirts to class. On the left, I have a picture of a brown shirt that a student possibly would have worn to class. It was hard to find an image of an actual university student wearing one, so here on the right is an image of Hitler at a youth rally. Hopefully that makes it easier to kind of make a mental picture of what it would have looked like for a university student to be wearing that. She was later fired from Göttingen for being Jewish, along with 6 of her other Jewish colleagues. Jewish students were eventually also expelled, and when people think about Hitler's reign, you think about how extreme the Holocaust was. As I mentioned, he didn't become Chancellor until 1933, so fortunately, things were not as extreme while Noether was living in Germany. However, female Jews, gypsies, asocials, the incurably ill, and chronic alcoholics were excluded from the welfare system and from entitlement to marriage loans, making it clear that the logic of Nazi welfare was not care, but racial selection. Moving on to Noether's theorem, the simplest definition would be every continuous symmetry in nature has a corresponding conservation law, and vice versa. In this context, symmetry refers to an operation that can be done to an object or system that leaves it unchanged, while conservation law refers to a physical quantity that remains fixed and hence does not fluctuate over time. Symmetry implies that certain quantities are conserved. According to Noether's theorem, the equation above expresses that concept. The quantities in the parentheses doesn't change over time. So basically, she was just able to create a relationship between symmetry and conservation laws. She also developed Noetherian rings, which are something that's prevalent in abstract algebra. At MJC, we're obviously doing elementary algebra, which consists of x and y's to represent numerical values. In abstract algebra, it includes things like rings, fields, and groups. A group is a set of operations that all follow the same axiom or mathematical rule. A ring is a mathematical structure that follows specific rules of addition and subtraction. And lastly, a field is another type of structure that follows specific rules for addition, subtraction, multiplication, and division. She studied rings, which led to the development of her Noetherian rings, which are rings that meet the ascending chain condition. Polynomial rings fall under that definition. Lastly, I would just like to share some fun facts about Emmy. For one, she loved dancing. She also ate dinner at the same restaurant at the same time every day. She ordered the same exact thing, except for on Sundays, because that's when she would cook for her students and take walks with them. She would also make them math pudding for dessert. It didn't say what flavor math pudding was, but I am thinking that it was chocolate. So that is my presentation. Here is my works cited. I hope you all enjoyed. Thank you for listening.